Students, today we will start chapter number 3 of class 10th, pair of linear equation in two variables. Now, what is linear equation first of all? Linear equation. As you know that equation of the form ax plus b is equals to 0. This is the linear equation in one variable, right? Because why it is linear equation? Because the degree is 1, so it is a linear equation. Now in the previous chapter you have learned ax plus b. This is a linear polynomial, but when we equate it with 0, this will become the linear equation, right? The degree is 1, so that is why this is called linear equation in one variable, because here only one variable is there. But in your chapter we are talking about linear equation in two variables. So linear equation in two variables will be written as ax plus by plus c is equals to 0. Right? Here two variables are there. So it means this is a linear equation in two variables. Again it is a linear equation because the power of the degree of both the variable is 1. So this is the linear equation. Here two variables are there. So it means this is the linear equation in two variables. But in third chapter you have pair of linear equation in two variables. Pair of linear equation in two variables means you have to pair means two linear equations. So this is, if you write another equation, ax plus by plus c is equals to 0. This is the pair of linear equation in two variables because two linear equations are there. Now in order to differentiate these two equations, what we will do? a1x plus b1y plus c1 is equals to 0. a2x plus b2y plus c2 is equals to 0. Now these are pair of linear equation in two variables. Now one condition is also there that a1, a2, b1, b2 should not be equal to 0. Why? Because now this is b2. a1, b1. If a1 will become 0, then this term will be cancelled out and only b1y plus c1 is equals to 0 is left. Then it will become linear equation in one variable only. So it means a1 and a2 must be not equals to 0, and similarly a2x plus and b2 should not be equals to 0. Right? So it means a linear equation in two variables. Pair of linear equation in two variables are a1x plus b1y plus c1 is equals to 0 and a2x plus b2y plus c2 is equals to 0. Now there are some conditions. If a1 upon a2 is equals to b1 upon b2. Now a1 upon a2 is equals to b1 upon b2. Now let us take an example. Let a2x plus 3y plus 2 is equals to 0. This is the one linear equation in two variables. And another is 4x plus 6y plus 3 is equals to 0. This is the another linear equation in two variables. Now you know that this is your a1 and this is your b1, a2 and b2. It means 2 upon 4, a1 upon a2, 2 upon 4 is equals to b1 upon b2, that is 3 upon 6. First of all we have to check whether they are equal or not. 2 ones are 2, 2 twos are 4, 3 ones are 3, 3 twos are 6. It means a1 upon a2 is equals to b1 upon b2. Now if a1 upon a2 is equals to b1 upon a2, this we have checked that a1 upon a2 is equals to b1 upon b2. Now let us check c1 upon c2. c1 upon c2 is equals to 2 upon 3, which is not equals to 1 upon 2, right? It means a1 upon a2 is equals to b1 upon b2 is not equals to c1 upon c2. And when we draw the graph of this type of equation, pair of linear equation, where a1 upon a2 is equals to b1 upon b2 but not equals to c1 upon c2, the graph of these two linear equation will be like that, two parallel lines. means no solution, and two parallel lines. Two parallel lines, right? We'll do graphically also in your next exercise, but you should know if A1 upon A2 is equals to B1 upon B2 but not equals to C1 upon C2. So by seeing the equations, by seeing the equation, you can say that the graph of these type of equations will be two parallel lines, right? Now let us take another example of pair of linear equation into variables. 2x minus 3y plus 4 is equals to 0 and 9x plus 4y plus 3 is equals to 0. Again, these are the pair of linear equation into variables. Now in this, if you check a1 upon a2, a1 upon a2 means 2 upon 9, b1 upon b2 means minus 3 upon 4, right? Here you can say that a1 upon a2 is not equals to b1 upon b2. a1 upon a2 is not equals to b1 upon b2. In this case, when a1 upon a2 is not equals to b1 upon b2, then in that case there will be no solution, and in this case exactly one solution will be there. Exactly one solution, and graph of these type of equations will be intersecting lines. Graph of these type of equation will be intersecting lines. Now next is now the next is, if you take an example of 2x plus 3y minus 9 is equals to 0, 4x plus 6y minus 18 is equals to 0, right? This is also the pair of linear equation in two variables, and we find a1 upon a2, that is 2 upon 4, b1 upon b2, that is 3 upon 6, and c1 upon c2, that is minus 9 upon minus 18. And if we solve it, 2 ones are 2, 2 twos are 4, 3 ones are 3, 3 twos are 6, 9 ones are 9, 9 twos are 18, minus and minus will be cancelled out. So 1 upon 2, 1 upon 2, 1 upon 2. In this case, a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2. So it means if this type of equation, if this type of situation will be there, then there will be infinitely many solutions of these two equations. Infinitely many solutions. And the graph, if you see that if both the equations are same, both the values are same, it means the graph of both the equation will be coincident lines. Coincident line means एक के ऊपर ही दूसरी line आ जाएगी, because they are same. If they are same, the graph will be same. So both the graphs will be same. It means both the lines will be coincident lines. Coincident lines, right? So these are the three conditions in which we can see, by looking at the equations, we can find out what type of graph of these equations will be there.